So we're going to go ahead and build on the previous lab that we were working on. In the previous lab, we built a gas flow run in Realflo. We're going to add a liquid flow run in this lab. So go ahead and hit update readings to go offline. Now that we're offline with it, you'll notice down here it says run 1, which is our gas run. We need to add another run to configure it. So go to configuration, setup, under setup. You want to change this to number of runs to 2. Once you've done that, double click on run 2. We're going to give this run a name of liquid run 2, or run 1, sorry. It's going to be liquid. You can select master flow. We're going to use volume pulses for this. So we're going to use the pulse input here on our board. If you change it, you'll notice the pulse frequency changes. So we're going to use that. So go to volume pulses. We use metric 1 for the input units for gas. We're going to use metric 4 for liquid. Leave everything else as is for now and move on to the volume tab. In the volume tab, it's going to ask you where is that pulse input coming in for this run. So if we go into telepace, we know that if we go into the register assignment, counter inputs, we know counter input 0 lands in 30,009. So that's what we're going to use. Leave everything as is, and we'll move on to the density tab. In the density tab, we are going to use analog input, the 4th analog input on our board as a density transmitter. It will be simulated in line with the volume pulse inputs that'll be coming in from our flow meter. So we're going to go ahead, we need the input register for it, so we'll go back into telepace again, go under our register assignment, analog inputs, and we want to use analog input 3, which is 30,004. We know from previous that 6554 to 32767 is 4 to 20 milliamps. Also the scaling will be 500 to 1100 kilograms per meter cube. So if you're getting 4 milliamps off that, it's 500 kilograms per meter cube. And if you're getting 20 milliamps, it'll be 1100 kilograms per meter cube. Move on to the water cut tab. In here you could either do a direct water cut if you have a water cut wired into the SCADA pack, or you can infer it off the density, and that's what we're going to do. So we're going to put in our base density of oil, which will be 650, and our base density of water, which will be 1000. So whatever it's reading on that density transmitter, so if it's reading 650 on that density transmitter, that indicates to us it's all oil. If it's reading 1000, it's all water, and Realflo will calculate anything in between. Next is the static pressure. It will also be a telepace integer. We're going to use the static pressure off of the gas run, and we know that that's register 30,002. The scaling 6554 to 32767. The 0 to full scale 0 to 20,000. We know we want to use gauge pressure, and we want to use our altitude, which is 1045, which will calculate the atmospheric pressure for us. I've already set that up in the gas run, so I'm not going to go over that in too much detail. Move to the temperature tab, same thing again. We're going to use the temperature off run 1, which is telepace integer. And we know that third analog input is our simulation for our temperature, which was 30,003. We know the scaling 6554 to 32767, and the 0 is negative 40, and the full scale will still be 200. Move over to the contract tab. We want to make sure our contract units are the same as our input units, which is metric 4. We want to make our contract hour 8, because that's what we made our contract hour of our gas run. We also want to change this. You'll notice that these units change when we go from the different contract units, but the values here don't change. But if you hit standard base conditions, it'll set those back to 15 and 101.325. Next, we can move to the liquid tab. You could give it this a meter ID and a meter bank ID if you like. I'm just going to leave those blank. You want to pick your product type, which is crude oil, as well as you could put in your K factor, meter factor, and your user factors here. I'm going to change this water volume correction type to API 11.4. I don't know what the product water density is, so I'm just going to use that. And then leave the two-phase detection and the run pressure compensation disabled for now. In the batch well test tab, we could leave that as is. We're not going to use it yet, and hit OK. Once we've done that, we can now write this configuration to the SCADA pack. We always want to pick selected configuration, flow run, and sensor config. Then I'll only write this flow run config and sensor configuration. So now that it's written to the SCADA pack, we can hit update readings. So this will give our live readings for run 1, which we know is the gas run. We want to select run 2 because we want to look at the liquid run. We could see that temperature and static pressure, volume, density, and water cut coming in. So right now we're getting 7 pulses per second. So if we change that, if we increase the pulses, you see more pulses coming in, as well as our densities right here. It looks like it's maxed right out, so we're going to bring it down a little bit. We want to stay somewhere in between 650 and 1000 here. So right now it's indicating that our water cut off of that density is right here, as well as our indicated density off our density transmitter, as well as our pulses per second off of our pulse input. So from all of these values, it's now calculating everything else. Same thing again is you could update reading 1, suppress, use any of these other features, as well as read the logs and history. So we'll go ahead and read that. Hit OK. Hit the event log. You'll see all the events here for the run that you've selected, which is run 2. Same with the alarms. And then we could go back and go into current run readings, as well as you could see hourly history and daily history. If you have this running long enough, we just wrote this, so obviously we haven't been even running for an hour yet, so we don't have any of that history, but that's where it all lives. As well as this is your current run reading, so you hit update readings and you'll see all the values here. You go ahead and play around with these values coming in, and you see how everything changed, and go from there.